For decades, the fight against Alzheimer's has been all about what's building up in the brain, toxic proteins and plaques. But what if we've been looking at this whole thing backwards? So that's the big question, right? And it's at the heart of some incredible new research. The idea is that maybe the first domino to fall in Alzheimer's isn't some toxic thing getting in, but something vital, something our brains need, just disappearing.
All right, let's get into it. The story really starts with scientists on a hunt for clues, and they're looking in, well, the most complex place you could imagine, the human brain itself.
To try and find that early trigger, researchers looked at brain tissue from 3 groups of people: folks with no cognitive issues, people with what's called mild cognitive impairment, or MCI. That's kind of a precursor stage. And then, of course, people with full-blown Alzheimer's. And they didn't just glance at it. They painstakingly measured the levels of 27 different metals, just trying to spot something, anything that was off. Now, you have to understand, for a long, long time, the thinking has been that a toxic overload of certain metals, things like zinc, copper, or iron, might be part of the problem. We know they can help cause those protein clumps that are the hallmark of the disease. So honestly, everyone was expecting to find one of these metals at crazy high levels.
But that's not what they found. Not at all. In a total twist, the biggest, most significant change, the thing that really stood out, wasn't too much of something. It was the complete opposite. It was the profound absence of one single element.
Out of all 27 metals they tested, just one showed this unmistakable pattern: lithium. And if you look here at the prefrontal cortex, an area that gets hit really hard by Alzheimer's, you can see it plain as day. The levels just go down, down, down. They're lower in people with that early stage MCI and even lower in those with Alzheimer's. This is a huge clue that this deficiency kicks in before the disease really gets its grip. Okay, so if the lithium is disappearing, where is it going? Well, this is where it gets really fascinating. The researchers found that those infamous amyloid plaques, the sticky protein gunk that clogs up the brain in Alzheimer's, they were basically acting like flypaper. They were literally trapping the brain's natural lithium, holding it hostage. And what that does is create this awful, vicious cycle. The plaques build up, they grab onto the lithium, and then the rest of the healthy brain tissue gets starved of this element that it desperately needs to stay protected. It's a feedback loop that just makes everything worse. But look, this raises the classic science question, right? Correlation versus causation. Is the low lithium just a symptom of the disease, or could it actually be one of the causes, a real trigger? To figure that out, they had to prove it.
And the way they did it was, frankly, brilliant in its simplicity. They took 2 groups of mice, including some mice that are specially bred to get Alzheimer's-like symptoms. One group gets a totally normal, healthy diet. The other group gets the exact same diet, with just one tiny thing changed. They took out all the naturally occurring lithium.
And the results? Whoa, they were absolutely staggering. Just look at this. The mice on that lithium-deficient diet, their brains filled up with amyloid plaques 2.5 times faster, just from that one dietary change. And it wasn't just the plaques. It was the other big villain in Alzheimer's too, the tau tangles. Their formation just exploded, going up by more than 3.5 times. Think about that. A simple nutritional deficiency was creating the 2 core signs of Alzheimer's disease. Okay, so you see changes in the brain, but here's the real gut punch. Did it actually affect their memory? Oh yeah, absolutely. The mice without lithium had much faster cognitive decline and memory loss. This was it. This was the proof. It wasn't just a correlation anymore. The lack of lithium was actively driving the disease. So, the big question is how? How can a lack of this one single element cause such a catastrophe? Well, the study digs into that, and it's like a domino effect happening inside the brain cells. To really get it, you need to meet a couple of key players in this drama. First up, there's this enzyme called GSK3 beta. You can think of it like a master switch that, if it gets stuck on, causes a lot of problems. And then you have the microglia. They're the brain's immune cells, basically the dedicated cleanup crew and security guard. So here's what happens when you don't have enough lithium to keep everything balanced. That GSK3 beta enzyme, that master switch, it goes into total overdrive. It's like a car with the accelerator jammed to the floor. And that directly ramps up the production of both plaques and tangles. But that's not all. At the exact same time, the microglial cleanup crew, they basically go on strike. They stop clearing out all the toxic gunk. And even worse, they get angry. They turn pro-inflammatory, becoming part of the problem and adding to the damage. So, this all leads to a really critical and hopeful question. If a lack of lithium is the problem, could putting it back be the solution? And this, my friends, is where the story gets really, really exciting. But there's a catch. You can't just use the standard lithium you might hear about in medicine, lithium carbonate. It's highly ionized, which just means it gets caught on that amyloid flypaper, just like the brain's own lithium does. So the researchers got clever. They tried a different form, called lithium arotate, which is way less ionized. The theory was that this version could be like a little stealth bomber, sneaking past the plaque traps to get the lithium right to the brain cells that need it. And the results in the Alzheimer's mice were just breathtaking. Even when they gave it to them late in the disease, this low-dose lithium orotate slashed the amount of plaques and almost completely wiped out the tau tangles. It wasn't just stopping the disease. It was actively reversing the physical damage. And this right here is the ultimate payoff. Because it wasn't just cleaning up the brain. The mice that got this plaque-evading lithium, they showed an almost 100% reversal of their memory loss. Their cognitive function was restored back to the level of healthy mice. It's just incredible.
So, okay, what do we do with all this? What does this mean for how we think about our brains and how we age?
First things first, and this is super important, we have to be really clear here. This is amazing, groundbreaking research in mice. It is not a proven human cure. We're going to need a lot more studies to see if what happened in the lab can actually help people.
Okay, so let's just recap the key takeaways here. What this all suggests is a huge shift in thinking. It seems like naturally occurring lithium is absolutely vital for a healthy brain, and a shortage of it could be an early trigger for Alzheimer's. That problem then gets way worse because the plaques trap whatever lithium is left. But, and this is the hopeful part, we saw in mice that a special plaque-evading form of lithium could actually reverse the signs of the disease. And that totally reframes how we see lithium, not as a heavy-duty drug, but maybe as an essential nutrient for our brains.
And that leaves us with this one, kind of profound final thought. You know, for decades, we've been searching for these super complex drugs to fight this incredibly complex disease. But what if? What if one of the most powerful tools we have has been hiding in plain sight this whole time? A simple, naturally occurring element, maybe as essential to our brains as a vitamin. If that's true, well, the answer to that question could change absolutely everything.